Okay, here we go. Section 3-4, we're ready for it. You got complex numbers. Boys and girls, boys and girls, boys and girls. You have one type of study called real analysis. This is a class you could take in college. It's a theory course required of math majors. Complex analysis is another course. Complex numbers are as such. You want to write this down. There's a real part. The real part is A. Then there's an imaginary part. That's the BI. So A plus BI is a complex number. And complex numbers, again, have a real part and they have an imaginary part. So that is something that we need to know. And it's important that we write them in that form. As Trent needs a sheet for notes because he leaves my room. Okay, there you go. So we want to be able to do operations of complex numbers. Now, so far, when we've been doing the rational roots theorem, we've only been talking about real solutions. What about imaginary solutions? And that's where complex analysis comes into play. Very simple. If you want to add two complex numbers, you add the real parts. So you have 4 and negative 6 is negative 2. Then you have 3 minus the negative 8i plus 11i. That's it. I'm going to rewrite this 1 minus I plus 3 minus I minus 6 plus 5i. So again, we just add the real part. So I have 1 and 3 is 4 minus 6 is negative 2. I have negative I and negative I is negative 2i plus 5i is 3i. And again, I write it that way. I write it the real part plus or minus the imaginary part. Any questions so far? All right, something else you should know is this. By definition, we know that the square root of negative 1 is I, or I squared is equal to negative 1. You guys learned that last year. We're going to refresh your brains with it, but that's important. Some people say, well, how do we know that's true? It's true by definition. And what that means is, how do you know a triangle actually has 3 sides? Well, we've defined it to be that way. Okay, that's what we've said a triangle is. So by definition, that's true. So if we use that definition, we have 7i times 4i, which is going to be 28i squared. And what is I squared? So we have 28 times negative 1, which is negative 28. And we have 3i times negative 8i. It'll be negative 24 I squared. I squared is, so we have negative 24 times negative 1, which is positive 24. So negative 28, we have positive 24. Common question among many students is, well, is it always going to be positive? Is it always going to be negative? No, it's not. You have to work it out. Negative 2i times a negative I. That's going to be a positive 2i squared, which is 2 times negative 1, which is negative 2. What if we have more than 2 i's in there? What if we've got 3? 6i times negative I times negative 2i. 6 times negative 1 is negative 6, times negative 2 is positive 12. And then how many i's do I have? I to the third power. Wouldn't you say that that's the same thing as 12 times I squared times I? And what's I squared? That'll be negative 12i then, right? I have negative I to the third power. Do I take the negative to the third power, or do I just take the I to the third power? Just the I. So we would have negative. We're going to square the I. We'll multiply it by I again. Again, what is I squared? Negative 1 times the negative would be positive 1 times I is just positive I. How about I to the 122nd? Julia thought she maybe had it. Julia says negative 1. Why? Well, we'll see if she's right, and if she is, if it was a lucky guess or not. Let's work this through. I to the first power is I, right? I to the second power would be I times I, which is negative 1. I to the third power would be I times I squared, right? So what's that? Negative I. And I to the fourth would be I squared times I squared, which is 1. So this is important that you understand this next step. I have negative 1, I have negative I, and I have positive 1. I to the fifth would be I to the fourth times I to the 1, right? Well, I times 1 is I. So I to the first is the same as I to the fifth. Casey didn't catch that, did you? You'll see. I got to figure out I to the 122nd. Watch. Right. So, as you see here, it's going to cycle through. So, if you have a power that's divisible by 4, it's going to come out to be 1. So, what's a power very close to 122nd that is divisible by 4? What number? 120 or 124. So, I to the 120th is going to be positive 1. So I to the 121st will be I. And I to the 122 will be negative 1. So you can see that you cycle through, it repeats itself. And so we know that I to the 122nd is going to be negative 1. So Julia was right. Julia, was it a good guess, or did you do that process? Was it an educated guess or a lucky guess? It was educated. Very good. Oh, now you're calling her a liar. What should we do? Should we kick her out? Okay. Oh, she just leaves. Quick, grab her cookie. We welcome you back. Julia, please. Oh, no. What will we do without you? I don't know how we'll survive. Ah, don't go, please. All right. Let's move on. Here we go. 3i times 2. 6i. 3i times negative 5i. Minus 15i squared. So that'll turn to positive 15. So you end up with 15 plus 6i. Yes, you must write the real part first. Yes, you must write the imaginary part second. Because I said so. Casey just asked a question. Give me a nice head bob. Head weave, I should say. All right, okay. All right, so here we go. Now we just FOIL. When you FOIL a binomial, you're used to getting a trinomial, right? Let's see what happens here. 2 times 2? 4. 2 times I. Negative I times 2. And negative I times positive I. Negative I squared. What happens to the middles? They cancel. And what is negative I squared? Positive 1. So you have 4 plus 1 is 5. Easy stuff, right? You guys getting it? All right. Then all we got is these other ones. Let's distribute this through. 6 times 3. 6 times negative 7i. Negative 42i. I times 3. 3i. And I times negative 7i. Negative 7i squared. What do the middles make? Negative 39i. What's negative 7i squared? Positive 7 plus 18. 25. All right, so we did adding, we did subtracting, we did multiplying. Now let's divide. 4 divided by I, or 4 over I. You can't have I in the denominator, so I multiply the top and bottom by I. And that will get rid of it for me. What is I times I? Negative 1. What's 4 times I? 4i. And 4i divided by negative 1 is negative 4i. I can do the same thing with the other one. I can multiply top and bottom by I. 2i times I. Negative 2. Negative 3 times I. Negative 3i. Negatives cancel. 3 over 2i. I wouldn't be that picky on the test, but there does come a time where the book will only write it like that. Sure. Sure, it doesn't matter. All right. If I multiply the top and bottom by I for this next problem, 3 over I plus 1, do they go away? No. If I multiply top and bottom by I still end up with an I in the denominator. We have to do something extra special here. Do you remember, this is very, very important, you see, so you're going to use this a lot in mathematics to come. Do you see that here, when we have 2 minus I and 2 plus I, we got rid of the imaginary portion? That's because it ends up being, I guess you could call it the difference of 2 squares. So the middles cancel, right? These two have a very special relationship. They're called conjugates. You guys have conjugations in Spanish, right? And a conjugation is where you change the ending, right? So we have the same thing in mathematics. And multiplying by a conjugate is a very, very useful step. If I multiply by the conjugate has the same beginning, but the end changes. And I can do that because I minus 1 over I minus 1 is equal to 1. So we multiply the top, and we get 3I minus 3 over, I have I squared. do I need to do the inside and the outside? No, those cancel. So I can do I times I, and then I know I will have minus, and I do 1 times negative 1 is negative 1. So I have 3I minus 3 over negative 1. Whoop. Sorry, guys. Sorry. So I get negative 1 minus 1. I end up with 3I minus 3 over negative 2. You cannot leave your answer expressed like that. It must be expressed as a real part and an imaginary part. So I'm not going to reduce parts by simply trying to cross stuff off. That's illegal. But I will divide each of the numerators by the denominator. So negative 3 divided by negative 2 will be positive 3 over 2. 3I divided by negative 2 is a minus 3 over 2I. That's your answer. Again, you can see that this is in the form of A plus BI. I can tell that A is positive 3 halves and that B is negative 3 halves. That's important because come second semester, we're going to graph these. And even furthermore, you guys are going to be able to take this and you're going to be able to find the 5th root of it, which is absolutely ridiculous, but we can do that. It's way cool. Your mind will go. You will never use it. Do you ever do a push-up in a football game? Not really. No, you really don't do a push-up in a football game. Yeah, after they score. So why do push-ups at all? Because it prepares you for the game, gets you stronger, right? So this is push-ups for your brain. Makes you stronger. Okay, last one. We got 2 minus I over 5 plus 2I. What's the last one? 2 minus I? Okay, this is a different scenario. We still need to get rid of the imaginary portion. And in order to do so, I multiply by the conjugate. The conjugate is 5 minus 2I. I'm going to do the bottoms first. 5 times 5. 25. 2I and negative 2I. Negative 4I squared. Now the top I need to FOIL. 2 times 5. 10. 2 times negative 2I. Negative 4I. Negative I times 5. Minus 5I. And negative I times negative 2I is positive 2I squared. Let's simplify the parts that we can. Looks like I'm going to have 10 minus 9I minus 2. When I square that I get a negative 1. And when you square 4I squared, you get a negative 4, so we'll end up with 25 plus 4, which is 29. Almost done here. I have 10 minus 2 is 8. Minus 9I over 29. Can I leave it in that form? No. So I divide each part by the denominator. I have 8 over 29 minus 9 over 29I. Real part and imaginary part. No, I won't mark it wrong. We had this is your assignment, 3.4, page 298, numbers 11 through 41, odd, and 42. Everybody thought that this was an OR. I said it's an and sign. Can't you see that? And they said, no, Mr. Gens, you need to improve your handwriting. Then for some reason I wrote Aaron's name on the board. I don't remember. And I wrote it in Greek. So, oh, she didn't like my eyes. She said your eyes need to have a little tail. Oh, for math they do. Oh, that looks like a 1. Okay, all right, that looks like a 1 with a halo. Okay. No, and 42.